Now my book says y equals here, so it's not. It's good to see it's not just me that makes these letter mistakes here. But assuming they mean x equals lambda t cubed e to the 2t, well, differentiating this. So differentiating this is going to give me lambda t cubed times e to the 2t times by 2, differentiating that. And differentiating that part there gives me 3 lambda t squared e to the 2t. Got to differentiate it again. So now this is just what we just differentiated there, but with a 2 in front of it. So this is going to be 4 lambda t cubed e to the 2t plus 6 lambda t squared e to the 2t. All I did was write that timesing it all by 2. But I've also got to do a product rule for this bit here as well, haven't I? So differentiating the second bit there just brings the 2 down. So I'd get that. And differentiating the first bit, that's now going to give me 6 lambda t e to the 2t. Grand total of all of that would give me some t cubes. Then I've got 12 lambda t squareds. And finally 6 lambda t's on the end there. So there's all the differentiating. What are we putting it into? So we're putting it into d2x by dt squared minus 4 dx by dt's and then plus 4x, and we want that to equal 3t e to the 2t. Right, I'm going to ignore all the e to the 2t's here, so ignoring the e to the 2t's to try and make this easier. So what we've got 4 lambda t cubed plus 12 lambda t squared plus 6 lambda, there's that bit, minus 4 of those, minus 4 times 2 makes 8 lambda t cubes, and I'm also taking away 4 of those, which is 12 lambda t squareds. Finally, plus 4 of the originals, so plus 4 lambda t cubes. Now, how many t cubes have we got here? There's 4 there and there's 4 there, and we're losing 8 of them there. That's good. All the t cubes are gone. We've got 12 lambda t squareds minus 12 lambda t squareds. That's good. All of those have gone. And all we're left with here, and is that right? Is that what it's supposed to say? No, there's a t there, isn't there? Phew. We've got 6 lambda t equals, what do we want it to be? 3t. And so that means lambda is equal to a half. Now we're not finished for the whole thing, because now we've got to do the rest of the equation. So the auxiliary equation for this thing here is m squared minus 4m plus 4 equals 0. So that gives us a repeated root of m equals 2. And so our answer is going to be a plus bt e to the 2t, that's from that bit there, and then plus the bit that's worked out earlier, a half t cubed e to the 2t. We can take a factor of e to the 2t out of all of that, can't we? So we've got a plus bt plus a half t cubed, and maybe that'll help when we differentiate it as well, that when we differentiate that, we'll get 2 lots of e to the 2t times by all of that, plus, what's this going to go to? This is going to go to b plus 3 over 2t squared times by e to the 2t. Putting in the numbers, and this is the numbers I put in wrong last time. So t equals 0, x equals 0, dx by dt equals 1. So in the first bit we've got 0 equals a, and that's all 0, so just 0 equals a, And in the second one down here, we've got, that was -1, wasn't it? No, it was 1. It was -1 on the last question. We've got 1 equals all of that. So that's going to give me B is equal to 1. I've run out of space, but you can put that into the answer. A is 1 and B is 1, and we'll stop.